All right, so before we get started, if you are having issues with like setting up your own cluster, or if the conference Wi-Fi is being frustrating, please raise your hand. My coworker over here will come along with a GCP account information, and you can use that GCP account to create VMs and run some stuff in VMs. So I'll talk a little bit more about doing that in a bit. Is it still a little quiet? Okay. I think so. All right. So welcome to Zero to Operator. Thank you all for coming today. For those of you who don't know me, I'm Solly Ross. I'm a software engineer on GKE and a maintainer of KubeBuilder. And my mission is to make writing Kubernetes extensions less arcane. So before we get started, let's quickly talk about some definitions. So to define an operator, we have to define a controller. So a controller is a loop that reads desired state, observed cluster state, and potentially some external state, so things like load balancers on your cloud, for instance, and then reconciles the desired state with the observed cluster state and the observed external state, and writes down observations at the end so that other things can see what we're doing. This is a relatively uncontroversial definition. All of Kubernetes functions on this model, everything from the deployment controller down to the node, even the scheduler. OK, so now that we have that in place, let's define an operator. An operator is a controller that has specific knowledge of an application. So for instance, the Prometheus operator knows how to manage Prometheus specifically. It knows how to take a bunch of rules from different namespaces about how to monitor applications, bundle them up into something that actually can be passed to Prometheus itself as configuration, and manage some number of Prometheus instances. So all operators are controllers, but not all controllers are operators. Some controllers just have general knowledge. So the deployment controller doesn't have any specific insight into what it's managing. All it knows is that it needs to do some rolling updates. All right. So generally over the course of this presentation, I'm going to talk to you about some concepts. Then we're going to look at some practical details. And then I'm going to pop over and try it out. And y'all can follow along and try it out as well. So we'll talk about scaffolding and design, and then we'll move into types. And then we'll move into the code that makes those types do something useful. And then finally, at the end, we'll talk about moving from your test dev loop into something that can be deployed on an actual cluster for production use. All right, so without further ado, perhaps a little ado. If some of you think you have seen similar things before, it's probably true. I've given some similar presentations before. But in this one, we're going to talk a lot about the new features in Kubernetes that make this even nicer. Some of the stuff that just came out recently. All right. So KubeBuilder. KubeBuilder is a set of opinions and building blocks. So there's kind of three components. There's KubeBuilder itself, which is scaffolding out new projects. And then that's built on top of two libraries. The first is controller runtime, which is like a standard library for writing controllers. And the second is controller tools, which is a set of tools to do stuff like compile your Go types into a custom resource definition that you can install in the cluster so that you don't have to write OpenAPI spec by hand, because that is not a fun experience, in my opinion. All right, so today we're going to be building an operator for the guestbook tutorial from Kubernetes. So who here has played around with the guestbook tutorial before at all? All right, so cool, some of you. It's a pretty simple application. There's a small front-end PHP application that connects to a Redis instance and then just basically lets you write in a name, stores the name in Redis, and when you load the page, it loads all the names from Redis. Pretty simple, but it has a few moving parts, and so it'll be good to explore kind of some stuff on how to write an operator. So we're going to manage and deploy both, and then we're going to expose the whole application in terms of a service. All right. So there is a repo for the finished code for this tutorial. Since we have an hour and a half, I'd recommend y'all take a look at that. That might help you, save you some time typing. It is at prez.metamagical.dev/KubeConUS2019/code. And I am going to give people a few minutes now to pull that up. Also, if you chop off the /code, you can follow along with the slides if you ever want to take a closer look at something. So this is all just on my website. Once you're in that repo, there's a directory called goals. That is like the YAML from the tutorial. So if you want to look at like the stuff that we're going to generate on the cluster, you can take a look in there. All right, so give like 30 seconds for people to copy down that URL. All right, so I sent out homework ahead of time. Hopefully, at least some of you have done the homework. But if you haven't, you're going to need a copy of KubeBuilder. You're going to want a copy of the complete repo, probably. And you might want to pull open the original tutorial in your web browser just to take a look, and it might help to compare and contrast what we're doing in the operator. So.
Does brew work? I mean, brew is the same version. Is there any reason not?
Oh yeah, you can totally, you can brew install, if brew has 2.2.0, you can totally install from brew. Yeah, we have a couple of contributors that maintain a brew repository. At this point, you're also, if you don't have a cluster up and running, you're also going to want to kick off launching a cluster. So I'm just going to quickly flip over to my terminal for those of you who don't have one, and I'm just going to show you what I did. So I already have one up and running for the sake of this tutorial, but so we can see I have created this VM here. It is a container optimized OS image because we're just going to be running a cluster on it for the most part. If you can't get other stuff running on your system, you might want to use the Debian image instead so that you can install other tooling. But I'm just using it to run a kind cluster. So I will just briefly show you what I did as we see if we test the internet right now. Cool. All right. So let me make this a little bit bigger. Size largest. There you go. Awesome. So for those of you who don't have a cluster, I'd recommend using kind. So the first thing you're going to want to do is download kind, which is here. If you go to the kind webpage, so kind.sigs.k8s.io, you can get this very long URL. So don't try to copy it from here. Just know that if you Google Kubernetes kind, you will find the right webpage. And then if you're on container optimized OS, you just need to move kind to var run, and then make it executable, like that. And then finally, you can do var run kind create cluster. And kick that off. It'll take a couple minutes. I'm going to pop back to the presentation, but it's good to get it started now. All right. Cool. On with the show. So, how do we get started with KubeBuilder? So what we're going to do is we're going to make a new directory. Since this is a Go project, we're going to initialize a Go module in it. And then we're going to scaffold out the basic KubeBuilder code. This will create some initial project structure, creating directories for our API types and for our controller, and give us some nice deployment files for later on. We give it this domain here. This is just the suffix that is put on the end of our API groups so that we don't clash with anyone else. All right, so I'm going to do that now. Pop over here. See, we'll create a new in progress. Can you all see that? Let me make it bigger. Go mod init, KubeCon. You can name this Go module whatever you want. And then we'll do KubeBuilder init -- domain. I'm going to use my personal domain. Please don't use this domain. This one's mine. You can choose whatever you want. If you have your own domain name, use that. You could use example.com if you really want to. It's reserved for testing, so. All right. And it's just going to scaffold out a project with the default dependencies. It'll hint at our next step if you want spoilers. If you don't want spoilers, ignore that last line. All right, cool. So, a little echoey. All right, so you heard me mention API groups a moment ago. So let's talk about how we describe Kubernetes APIs, and I'll explain what API groups are. So, in Kubernetes, we collect API types together. And so we call each collection of related API types an API group. API groups can have multiple versions. This is how we make breaking changes to APIs in Kubernetes. We add new versions, and then we convert between them. And within that API group, we call each type a kind. Now, this is most of what you need to know to talk about Kubernetes API terminology. But there is one more thing that may come up if you get really deep in. You may also hear people talk about resources. A resource is a use of a particular kind in the API. Usually they're one-to-one, but not always. There's a few exceptions in certain parts of the Kubernetes API. So just, you can think of resources as functions and kinds as return types, but usually in Kubernetes we only have like one set of functions that returns a given return type. And so when we have Go types, usually each of those Go types corresponds to a single group version kind. All right, so the structure of almost every Kubernetes kind looks roughly like this. So all of them start out with some metadata. This provides information about what kind we're dealing with, what API version. In this case, we're looking at the pod in the core v1 group. For historical reasons, we don't write the core, but it's kind of implied. And then there's also some what we call object metadata. So this is things like name, namespace, labels. Hopefully you all are familiar with that. And then almost all other types, have spec and status. So the spec contains the desired state, and the status contains the observed state. All right, so practically speaking, the way we get started here is we call KubeBuilder create API. We pass a group name, and that'll get our domain appended. So if I say group web app, it'll be webapp.metamagical.dev. We give it a kind name, so we'll say guestbook here. And then we give it a version. We're going to be bold, and we're going to decide that we're going right to stable. Pro tip, don't do this. And that'll give us something that looks like this for our API types. So you can see up top here, we have our spec, and then we have our status, and then we have this root object, which contains our metadata, so type meta and object meta, so that's like API version and name and namespace and stuff. And then it also contains our spec and our status. And finally, we have this list type. As you might guess, this is the type that's returned when we call lists. So if we do kubectl get without a specific name, it goes and says to the API server, give me all of the pods, and the API server returns this kind of wrapper type. All right, so let's look through each of those sections. So first up is the root type. We don't usually edit the Go code of the root type because it almost never changes between types. But what we do is we can add additional metadata to the root type. This describes more information about our CRD. So the common things that we do is we enable sub-resources and we add print columns. So we'll talk about the status sub-resource a little bit later in the tutorial. But for now, just know that we enable it here with this marker comment. So that's that comment that begins with a plus. And then we also had print columns. Print columns are the way that we can get nice kubectl get output. So like with core types, if I were to do kubectl get pods, I would see like some nice columns that would show like node name and maybe pod IP and stuff like that. Status, whether or not it's running or terminated or in progress. The way we do that for CRDs is we add these print columns. So here, we've added 2 print columns. We add one for URL, which we're going to be exposing in our status. And we add one that shows the current desired replicas from our spec. And this way, when we type kubectl get guestbooks, instead of just seeing name and like creation timestamp, we see like some useful information that is a summary of all of our guestbook instances. All right, on to the spec. So spec describes desired state, like we said before. So we need to decide what we want to put in here. So I've put in 2 kind of fields in the root of the spec. One of them is the name of the Redis object that we're going to use to fetch our connection details. So we'll also have a Redis kind, and we will use the Redis's status to know how to connect our deployment to Redis. And then we also have details about how to deploy and manage our front end. So I've added resource requirements so we can control how much CPU it uses, and also information about the service and the number of replicas. And you can see we also can use markers here, marker comments. This time they go on fields, and they control stuff like defaulting and validation. So we actually have a pretty powerful language in OpenAPI, and all of that is exposed through these markers. So we can say, don't let people submit ports that are negative, because that doesn't make any sense. If they don't add a port, make it 8080, because that's a sane default, for instance. And we can say that certain fields are optional. So like port is optional, we'll default it. All right, status is very similar to spec. There is one thing to note here as you're thinking about your APIs, which is to say status is used to convey information to the user and to other controllers. It is not for storing things. So you should think about status as kind of ephemeral, right? Like imagine at any time someone could come through and delete your entire status. You need to be able to recreate it from everything else. So a given controller that's writing status to its own object should not be reading in that status. It should not be depending on information there. It's for it to communicate information out to the world. Right. So we're also going to need Redis types, kind of similar to what we talked about for guestbook. Redis has one leader and some number of follower instances. So we let you control the follower replicas. Couple things to note here. We can use Godoc to set basically API descriptions that come out in our OpenAPI. This is nice if people are using nice UIs or IDEs that give them help when they're writing their YAML. And it also shows up in kubectl explain. So if someone says kubectl explain guestbooks, it'll read from the OpenAPI, and it'll show like follower replicas is the number of follower instances to run. So, all right. So if you were paying super close attention, you might have noticed that when I defaulted 2 fields in the guestbook, I used slightly different types for them. So one of them was a pointer, and one of them was not a pointer. This is a little bit of an important point in Kubernetes. So if we don't have a pointer, the 0 value is assumed to mean unset. So in the case of integers, for instance, that means 0 is the same thing as I didn't fill in a value. And so the default will always be applied even if the user passes 0. So this is great for things like port, because 0 is kind of a nonsensical port. But it's not so great for replicas, because it means we can never stop our thing, right? So the solution to this is to make the 0 value something else. And the way we do that is by using a pointer. So if the 0 value of a pointer is nil, which means unset becomes nil, becomes a default. But if it's explicitly set to 0 in the YAML, that becomes a pointer to 0. And we don't do our defaulting. So we let our users scale down our things, which is good, because sometimes they won't want it running. We can use almost any type in Go in our spec and status, with a few exceptions. We don't use floats, because for those of you not familiar with how floats interact, and they're very good at what they do, but that what they do is probably not what you expect. So they don't round trip very well through JSON and YAML, and through other languages. So we use a different representation instead, called resource.quantity. You've probably seen it when you're setting your pod resource requirements. We also don't really use interfaces in our APIs. We prefer these kind of tagged unions down here, where we have an explicit type field, and then multiple kind of variant fields that are generally pointers to things, or things with zeroable values. All right, so let's try this out. So we're going to populate our scaffolded out sample. So by default, KubeBuilder scaffolds out kind of an empty sample with some bogus data in it. So we can fill that out. I'm going to add some bad data that's an invalid field into mine, just so that we can see that validation is working. And then we will actually pop over and generate our CRD from our Go types with make manifests. We will install our CRD with kubectl create, and we will attempt to install our sample. It will fail, and then we will install it again, and it will succeed because we will remove the bad data. And we will be able to run kubectl get guestbooks, and it will work. So let's try that out. Just going to flip back over to over here. So first, I'm going to fill out, I'm going to do all that stuff we talked about at the beginning. So we'll do KubeBuilder create API. We're going to get an API, and it's going to ask us, do we want to create a resource? We're going to say yes. That's, do we want to create those Go types? And do we want to create a controller? We'll also say yes. We'll deal with that in a little bit. So it's going to scaffold out some types. It's going to attempt to run Go imports to clean it up a little bit. And then we've got these scaffolded out types. So I am going to cheat a little bit because I am standing up here. And I'm going to copy over from the completed tutorial. So API v1 guestbook types. And then we'll also look at, here we go, API v1 guestbook types in this. We're going to open that. Split so y'all can see both sides. We can see we've got this empty here. We've got this complete here. So I'm just going to grab my spec fields from here and copy them over. Get rid of this nonsense. And then you can see we have like this nested front-end spec, so we'll also need that. And then finally, our status with just the URL. We could put other information in here too, but oftentimes we have stuff like status conditions that convey kind of what the current state is of the deployment of the thing. So like, did we create our service successfully? Did we create our deployment successfully? And then finally, I'll also copy in all of those markers that go on our root type over here. And then finally, last but certainly not least, since we use that core v1.resource requirements, that's the same kind of structure used in the pod container resource requirements, we'll need to import core v1. And then my compiler is happy. So I'm all set. I can run make manifests. Oh, one more thing. Sorry about this. So we're using brand new features. And so we've got to tell controller gen that we want to generate in the new format with those new features. So this was just launched in Kubernetes like one version ago. And so by default, we don't generate that so that people get projects that work on older versions of new Kubernetes. But here, we like living on the edge. So we're going to say, use the GA version. So we open up the makefile and say CRD versions equals v1 as opposed to v1 beta 1. And let's try that again. Cool. All right. So let's take a look at that quickly, just so you can see all the stuff you didn't have to write. So we'll do config CRD bases. And you can see we get this nice open API spec that has all this validation in here. We get some defaulting. You can see we had that defaulting on replicas with a default of 1 and the minimum of 0. And you can see that we have all of this nice resource requirement stuff in here, too. So let's also edit our sample. So it's under config samples guestbook. And we'll give it a Redis name, since that was required. So Redis sample. We'll generate the Redis one later, a little bit later. And then we'll give it some front-end configuration. So we'll say resources, requirements, or requests, sorry. Say CPU 50 millicores. It's not a big application. And then we'll also say serving port :-1. And that's just invalid, right? We can't have a port of -1. And so our validation will catch that. All right, so at this point, all of you should have a running kind cluster. If you were on GCP, it should be up and running. And if you were not on GCP, your local cluster should hopefully be running, or your remote cluster or whatever, whatever you're deploying onto. So what I did, because I'm running against GCP, is that I SSH'd into the node, the compute instance. I grabbed the kube config that was generated by kind. So kind will say, your kube config is now set. It's at ~.cube/config. So I copied that to my local machine. And then I'm going to run this fancy port forward command. And I will show you how to figure that out in a moment. So full commands over here. And then I'm just going to grab this thing here. So basically, this is just the default gcloud SSH command that you will get if you press the little drop down next to the instance box and say next to SSH and you say SSH with gcloud. And then we're going to pass this -l here and -f and -n, which is going to port forward from my local machine to the remote machine. And so we're just going to use the connection string we got from the kube config. So I'll show you how to get that in a moment, but we're just going to run this here. -f and -n just say, no, I don't actually want to run a command. Just go into the background and port forward. And with any luck, we should be able to do, cool. So we have a working cluster. All right. So let me just show you console.clouds@google.com. And we'll go under our compute engine instances here. And then, so the way I got that crazy command was I just went down to this little drop down here, and I said, view gcloud command, and you just copy this whole thing. And then at the end of it, you just add -- and then -l and the port, and then the connection string from the kube config. So please, if anybody's having issues with that or is confused, please raise your hand, and we can have someone come over. All right. So now that you hopefully have a running cluster, let's install the CRD. Right? And we'll also attempt to create our sample. And we're going to get this nice message here. See? So our validation is working. It said invalid value spec.frontend.serving port should be greater than or equal to 0. So we're going to go into config samples and get rid of serving port here. And then we're going to try again. It works because we provided valid data. And then if we do kubectl get guestbooks, we can see we have this nice table display that shows us useful information just because we put those markers in place. We don't have any URL because we don't have any controller to set the URL. So let's tackle that. I'm going to give everybody a couple more minutes first, though, to try this out. And remember, all of this stuff is in the completed Git repo. So if you are having trouble, or you think you typoed something and you can't figure out what it is, or if you just don't feel like typing, I frequently don't feel like typing. That's why I have K alias to kubectl instead of having to type out kubectl all the time. You can just go from there. And if you really don't want spoilers in that repo, I've got the exact git commit where you should be checked out to in the completed repo if you really want to just follow along exactly instead of just using the end. All right, and feel free to raise your hand if you are having issues. And/or if you think there's something that's very confusing, you can also ask the question out loud, and I will try to answer it on stage, because it may be confusing for other people as well. What'd you say? Slow down a little bit? Yeah, I'll give you all a few more minutes. And as a reminder, if you would like to look back at any of the other slides, if you go to pres.metamagical.dev, which I can show you now, you will get this web page if the conference Wi-Fi is working, and you can just click on this link here that says 0 to operator. We'll zoom in a little bit. This link here that says 0 to operator, and you will actually just get a copy of the slides. So if you would like to look at the slides at all or look back a few slides or whatever, you can follow along there as well. You can also look forward a few slides, but that would be spoilers again, and that's no fun. If you want to ask a question, you can also come up here and I'll repeat the question out loud if it's like you think it's relevant for everyone. Actually, I'll come down and help some of y'all too, just to expedite this. All right. Make file. Yeah, so I got a couple of good questions. The first one is, what was that makefile option? And it's CRD versions, plural, equals v1. And you can see that in the completed repo too. And the other one is, if you get this weird error about Go dependencies, that occasionally happens due to the way Go likes to resolve dependencies. If you go into your go.mod file, you should see, if you're encountering this issue, you should see two lines, one that says controller runtime and one that says kates.io/client go. If you delete the line that says kates.io/client go, and then you rerun like go build or go mod tidy or something like that, basically any of the commands that affect Go modules, it will attempt to re-resolve dependencies and actually use the right version. Basically, Kubernetes Go dependencies management is like halfway to Go modules, and so occasionally it gets a little bit weird. Oh, that change is in go.mod. So it's your go.mod is your dependency list, right? It's like your versions of all your modules that you're using. The question was about the new features we're using in our CRD and what versions will this work with and why are we turning on this feature? So this is actually about things like defaulting. So those are only turned on in the GA version of CRDs. And generally, you could hypothetically write a controller that assumed the defaulting was not going to take place and like backup defaulted, but use the CRD defaulting if it was available and just generate two different versions of the CRD. That's actually why the option is plural. You can actually specify multiple versions there and install a different version depending on what cluster it's running on. That's kind of a little bit more advanced than this tutorial, I think, so we're just going to stick with stuff for the newer version. When you do KubeBuilder create API, it'll ask you two questions. Say yes to both of them. Yeah, so actually, if you had that failure with the dependencies, it's just a failure attempting to build, I believe. You should have all the files still there. Okay, so if you then deleted them, you can go into your project file. It's just called project in all uppercase, and there's like a list of types. And if you just delete it, you should be able to run the command again. Just a reminder, so you will need a 1.16 or newer, technically, if you're compiling from head cluster. So that's why we're using kind today, for instance. Anything older, you'll get messages about the V1 CRD not existing, or if you try to generate V1 beta 1, it'll yell at you and say you're not allowed to use defaults in V1 beta 1. Okay, so make sure if you're missing config crd bases, make sure to run this first command, make manifests. That will generate your CRDs and put them in that bases directory. That's probably it. All right, quick show of hands. Who has managed to successfully run kubectl get guestbooks, this last step? All right, who has gotten mostly the way there and hit some speed bump? Okay? And who is still waiting for their cluster to finish creating because of internet issues? Okay. So for the sake of time, just to make sure we get through everything, I'm going to advance along a little bit. And then if we have time at the end or at the next break, I'll be happy to come around again and help out. And Walter can also come around and help you out. All right. So we have our types, and this is awesome. But at this point, Kubernetes is effectively acting as a structured key value store, which is like great, but we probably actually want to do stuff, right? Deploy pods, run workloads, all that jazz. See URLs, have things show up in our browser. That's the fun demo endpoint, right? All right, so let's talk about how we make things go. So when we talk about Kubernetes and we talk about controllers, the core concept that we talk about is reconciliation, reconciling our observed and desired states. And so generally in Kubernetes, reconciliation follows like a standard pattern. This is followed by almost everything in Kubernetes, be it custom operators, custom controllers, built-in controllers, even like the kubelet. So we read our root object, the main object we care about for any given controller. We fetch all the other objects we care about. So these might be objects we created, objects we're reading information from. We ensure the objects we created are in the right state. We ensure that our external state, things like load balancers, databases, et cetera, are in the right state. And then we write back what we did into our object status. And then we repeat over and over again. So let's take a look at what that looks like in code form. So this is a little small, but we'll go over it in more detail, and I can zoom in a little bit. But this is, in essence, the entire reconciliation loop for our guestbook controller. So we can see we start out, we get this reconciliation request here, and that contains the name and a namespace for a guestbook. So what we're going to do is we're going to attempt to load that guestbook. And then once we've loaded that guestbook, we're also going to attempt to load the Redis instance that it references. So we're going to look at spec.redis name, and we're going to construct a key, basically a name and a namespace, and we're going to say load the Redis named spec.redis name in the namespace that's the same as our guestbook. And then, using information from that Redis' status and our guestbook spec, we're going to construct the deployment to run our guestbook front end. And then we're also going to use the information in our guestbook spec to construct the service that exposes that deployment to the world. And then finally, we are going to submit those changes to the API server and update our own status, and then update the value of our status on the API server. And finally, we return this result value. That result value says, things completed successfully, and we don't need to requeue. So if we needed to do periodic updates, or if we needed to check again later because, say, we're reconciling some external status that doesn't implement this kind of watch mechanism that we have in Kubernetes, we could say, like, requeue after 10 seconds to check again in 10 seconds. But we don't need to do that. Also, if we returned an error here as this second value, we would get automatically requeued with backoff. So if we failed to do something, we can just return an error, and our mechanics will try again later, but backing off so that we don't just keep trying really quickly forever. All right, so you might have noticed there were a couple helpers there. I kind of moved them out so that it would be easier to go over the structure of the code. But the helpers are actually pretty simple. So normally in Kubernetes, we need to be make sure to be idempotent with our changes. Right? So what this means is if our object is in the right state already, we don't want to accidentally reset any fields that someone else set or change things. We just want to make sure that everything is in the right state that we care about. And so previously, in older versions of Kubernetes, this was kind of hard. If any of you have seen any of my previous presentations, you'll know that there's like a couple pages of code just to do this. This has gotten a lot nicer with a feature called server-side apply, which I like to call the Picard patch. So what server-side apply lets you do is it lets you declare the object in YAML or JSON form, and you just set the fields that you care about. And you always set all the fields that you care about. And then you tell the API server, make it so. And the API server figures out what changes, if any, need to be made to the actual object. And this allows multiple writers to make their changes and just say, ensure it's the way I want it, without stomping over each other. So here, even if, say, the service controller populates some more information or adds some defaulting in, even though we haven't specified that defaulting, we're just constructing it from scratch every time, we won't clobber out those changes. And so you can kind of see this Go code almost just looks like we've written Kubernetes YAML in Go. And that's basically because we have. It's very similar to how kubectl apply works, but way more powerful because multiple writers can do it, and it's on the server, so we don't need any special logic client side. The one other thing that we're doing here is we're setting an owner reference. This does two things. The first is that when we delete our root guestbook object, it'll make sure that our service and deployment are also cleaned up. This is called garbage collection in Kubernetes, if you want to Google for more information about it. The other thing it does is a little bit later on, when we go to wire up our reconciler so that it's actually called, it lets our controller machinery know when you see changes for this deployment, it's actually, we need to re-reconcile this guestbook instance. The other one here is pretty similar. It's how we construct our status information. You can just see we load the service, we set some fields. We always set the value. So if we don't have any information, we explicitly say that. And if we do, we say that. All right. So now we just need some wiring. We need to tell it when to run. We have our logic in place, but it's not going to do anything. So when we talk about wiring Kubernetes controllers, we talk about relationships between objects. So each controller is for a single kind. It can have other kinds that it cares about, but there's this kind of root kind that the reconciler functions in terms of. And so our case, for a guestbook controller, the root kind, as you may have guessed from the name, is guestbook. And then we talk about two types of relationships. One is a very common relationship, and that's the owns relationship. This is for objects we create. So we define that relationship in terms of that owner reference that we just set. And then there's another relationship, which is more free-form, called watches. This is for objects we didn't create, we probably don't modify, but we do care about some values in them. So in the case of our guestbook, if we flip back a couple slides, we can see that we pull information, specifically, we pull, we actually don't have it here, hold on. We'll see in a moment. We pull information for constructing our deployment, that was just the service, from the Redis status. So we care when the Redis status changes because if it changes service names, we need to know so we can update our deployment configuration. So we say that guestbook watches Redis. All right, so what does this look like in terms of code, practically? So you can see basically our reconciler logic goes in this method called reconcile that implements the reconciler interface. Basically, what we saw before is everything in the reconciler. The only difference is we set up some context and logging information just so that we can see what's going on. And then we put all of that code that we just wrote in the middle here. Should look fairly familiar. All right, and then we need to register that reconciler with a controller that knows how to trigger it. So we say we want to create a new controller managed by a manager. The manager is just responsible for setting up watches and all the boilerplate and running our controllers and waiting for signal handlers, all that like boring stuff that actually just we don't really care about, but we need to do for everything. And then we say that this controller is for guestbooks. It owns services and deployments, just like we talked about, and it watches Redis instances. Now, watches, as you can see, is a bit more involved. Because it's an arbitrary relationship, we need to specify what that relationship is, and we do that using a mapping function. Now, the mapping function needs to be able to map from a Redis instance back up to a guestbook. And so to do that, we need to be able to quickly look up what guestbooks reference a particular Redis instance. And so we do that by setting an index. You can see this index is pretty simple. Basically, we just say, what is the Redis name? And then we index on the Redis name. And we'll see, we'll use that in a moment in our mapping function. So the mapping function is also pretty straightforward. Basically, the meat is this function right here. So all we're doing is we're saying, given some particular Redis instance, list all of the guestbooks, but filter on that index we just set up so that we only get the guestbooks that match, that have spec.redis name as whatever the thing we're reconciling is. And then once we get all the guestbooks, we just convert them into these reconcile requests. And all that is just a name and a namespace. So all we do is we go through each of the guestbooks, we pull out the name and the namespace, and we put it into this reconcile request object, and we return it. And then our controller pushes all those onto the queue to get reconciled. All right, so that was a lot. So we're going to actually try that out now. What I'd recommend is that you copy and paste that from the completed repo. You totally can take the contents in the presentation and copy them in or write it out by hand. But I'm assuming most of you, like me, are a little bit lazy and wouldn't want to type all of that deployment Go object out. So I would recommend copying and pasting it. And then once we've done that, we can run make run, and that will run the controller locally against our remote cluster. This is super useful for dev test cycles because we don't have to bundle it into a Docker image and then deploy it on the cluster, wait for it to deploy. And we can even do stuff like run it under delve to debug if something goes terribly wrong. So we're just going to try that out. So I am going to go and copy over the code myself, and then I'll come down and answer questions from y'all. Yes, sorry about that. To remember what the directory was called. That's easy. OK, cool. All right, let me make that bigger. Cool. So I'm just going to go into controllers here, and we see we have this guestbook controller. And it kind of looks like what we just saw. We have this empty reconciler. So I'm going to split with the completed one. And we're going to grab the complete controller, which is effectively just what we went over before. Right? Ignore some of this extra stuff on top. We'll talk about that in a bit. And I'm just going to copy, go over, move the internals of the scaffolding here, copy all of this stuff, which is just what we saw exactly, and I'll paste it back in here. And then same thing with our setup here. And I've actually moved those helpers that we saw out into their own file, just for organization purposes. So I'm going to copy that over. We're also going to need all of the core API types that we referenced. So let's put those in place, too. All right. So basically, these two are the Kubernetes API types for deployment and service. And these three are the bits that we need for writing that watches relationship. All of this has GoDoc, so if you're interested, you can go and look at the GoDoc as well. It's at godoc.org/sigs.k8s.io/controller runtime. There's a link at the end of the slides, too. right. So this is currently going to complain, if I had to guess, that we don't have any of these helper methods, and we don't have a Redis instance. So I'm going to really quickly create the Redis instance too. I'm going to copy that over. I forgot to do that earlier. Complete API. Redis -- version v1 -- group web app, just like we did. There we go. Just like we did for our guestbook. It's going to complain. Then I'm going to copy over all the stuff that we're missing. And then we'll copy over that helpers file, which is exactly the code that we just talked about. Under controllers. Cool. And so now, with any luck, let's do export config. Just going to do that. With any luck, we should be able to do make run. Actually, let's regenerate for that's why. Sorry, copied some stuff incorrectly. Let's fix that up. Perils of live coding, right? So we called this KubeCon instead of workshop code in this version. So we just need to make this KubeCon. All right. Let's try that again. Cool. So we'll install our Redis CRD as well, since I haven't done that yet. I don't know if any of you have, but I haven't done it. We'll make sure kubectl is on my path, and then we'll do that. All right, cool. Now we should be able to do make run. Aha! We can see we've got this log line that says successfully reconciled our guestbook controller. So we have a running controller for guestbooks. A little bit later, there's also code in the repo for the Redis controller. I did not cover it in the presentation because it looks almost exactly the same as the guestbook controller. Instead of creating one deployment in service, we create two deployments in services. That's basically it. OK, so let's take a look at the time. Cool. I'm going to give you all some time to try this out. If you are confused or unclear about anything or something's not working, as always, raise your hand. Let me just turn.
inside.
Just to reiterate, if you're looking at the complete repository, you'll also see those Redis types I just mentioned and the Redis controller. So for the final full working thing, you'll also need the Redis controller. If you've got the guestbook controller up and running and you're curious, you can look at the Redis controller, but it should look very, very, very similar to the guestbook controller. We walk through, we create 2 deployments, one for the leader, one for the followers. We create 2 services, one for the leader, one for the followers, and then we write down the leader and follower service names in our status. Oops. Again, if you're getting that error with like wrong number of arguments in watch, it's basically due to pulling too new of a version of client Go. So if you go into your go.mod, you should see a number of lines that start with just cates.io. It should be API machinery in client Go and API. If you just delete those and then run make run, Go will reevaluate the dependency graph and find the right versions. This is actually a good point to bring up. So modifying our controller does not change our CRD definition. So once you add the Redis types in, the only thing you need to reinstall, hold on, is the Redis types. The guestbook types haven't changed from when we generated them before, even though we've changed the controller itself. The controller does not affect the CRD types. And one other note, if you are running in kind due to some last minute changes, that URL is not going to show up because it's waiting to see a load balanced service. So we could, and I will if you want, if we have time, modify the service status code to, instead of looking for a load balance service or waiting for a load balance service, just do a normal service and put, say, the Kubernetes API prefix in there instead. But it's basically the same premise. As a quick show of hands for a status check, how many of you have gotten make run running? Right? How many of you are still copying code? How many of you have not gotten to this slides point yet and are still trying to work out stuff from the last pause? Okay. And last but not least, how many of you are encountering issues with make run? Cool. All right. I will try to come around. If you have issues with make run especially, raise your hand and I'll try to come around and figure out what they are, and hopefully we can take care of some issues for the group. So if you are running locally, you are Docker pulling over conference Wi-Fi on your cluster. This may take a while. Yes, you should see a deployment. All right. Okay, so if you copy code over from the completed workshop, make sure you change the import path. So like my import path for the sample workshop code was workshop-code as the base. But if you did go mod init my KubeCon, you're going to have to replace workshop-code with my KubeCon, for instance. For those of you who are not seeing a set of deployments, as I am, we have a quick fix for this, and this is because I was lazy and did not add sufficient logging to my controller. So this is a lesson to y'all. Make sure you have good instrumentation. So, let's figure this out. This is a good learning opportunity. So something's going wrong in our guestbook controller. It's not creating our deployments. I'm going off the script here. Let's hope it works. All right, so something's gone wrong. So the first thing we probably want to do is we want to add some logging. So let's do this. We'll say got Redis. Now I'm cheating a little bit because I have a very strong idea of what's going wrong. And then we'll give controller runtime uses structured logging by default, so we can cast key value pairs after our message. So in this case, we're going to say got Redis, and then we'll give the Redis name. So redis.name, like that. All right? So now we're going to run make run again. And we should see that we don't actually see got Redis. All right? So if I had to guess, or we got an empty Redis. So let's try that again. I'm guessing that we're hitting an error there. Yeah, see, there we go. Didn't get Redis. And that's because we never created a Redis instance. Whoops. So let's edit our Redis sample. There we go. That was rather quick. All we did is set the follower replicas to 1. I think we set a default for that by default, so we didn't even need to do that. But we'll do it. And then we're going to do all right. Let's try that again. And in fact, we should there we go. So we see we got this got Redis line, and we can actually see this is kind of cool. With our structured logging, we have these key value pairs here, and we see we got the Redis name. So let's try that again. Ta-da! All right. We actually have something that works now. Cool. So I'm going to move on because we're running a little bit low on time. And then at the very end, I'll be happy to come around and help anyone out who's still having issues. All right. So before we are done, we need to talk about how to package this up and run it on the cluster. So there's two things we need to talk about, and the first of which is permissions. So right now, I'm guessing y'all are running the controller as cluster admin. This is not great. Do not run all of your controllers as cluster admin. I can safely say this without being a security person. So the way we control permissions in Kubernetes is generally through something called RBAC, role-based access control. RBAC functions in terms of roles, as you might have guessed, and bindings of users to those roles. So by default, we generate a role binding that binds the default service account that's like a user for a controller in the namespace we're running to this role that automatically gets created by KubeBuilder. KubeBuilder scaffolds out markers to generate rules for that role that let us read our own types. But since we're also reading and writing other types, we need permissions to read those too. So we'll add these two markers in here. So this one says, for the group apps and the resource deployments, we're going to allow list, watch, so we can list and watch and trigger reconciliation. Get, that's so we can fetch. And patch. Patch is the underlying verb behind server-side apply. Same thing with services. We need to get, list, watch, and patch. So that'll generate these roles, and then when we run make manifests, it'll regenerate. Right. So the other thing that we probably want to talk about is running this properly. So KubeBuilder scaffolds out makefile rules to build and run your controller as a container on the cluster, as a deployment, in fact. So this first command here will actually build all your Go code, and then it will push it up to a registry. So for those of you who have GCR or GCP accounts, you can push to GCR if you'd like. So you get GCR / your project name / and then whatever you want. And then we should be able to deploy, and that'll just launch a deployment on the cluster with that image that runs our controller. And if all went well and we're running both the Redis controller and the guestbooks controller, we should actually have a functioning guestbook instance. All right, so I'm going to switch back here, and just for quickness' sake, I'm going to switch to the complete one, because that's got everything all set. And then I'm going to cheat a little bit. I don't actually want to do all these Docker operations on my laptop because it's going to be slow. So I'm going to run them with Google Cloud Build, which is like Docker Build, but on GCP. So while that's running, I'm going to come around and see who else has questions. All right. As a show of hands, who was able to run make run from the last step? Who's still stuck at like the make run portion? Right? And who's stuck before the make run portion? One? OK, cool. All right. Keep your hands up, and I will come around to help out. Reminder, at this point, you can basically just go to the end of the completed repo. So like where you originally cloned, or you can go to that SHA at the bottom there. But basically, we're at the end at this point.
Anybody is all finished and wants to do some further reading or investigation, you can go to book.kubebuilder.io, and there's other tutorials there and whatnot, just in case any of you have to scoot now or whatever, and want to see that before I advance to the next slide. Since we're roughly out of time, I'm happy to continue staying around helping people out, but I figured I'd advance the last slide. There's some resources up here if y'all want to learn more. And thank you all for coming out.